Hello, I am Abhishek Mall and welcome you all to the live session 1 of the course Manufacturing Process and Technology First and Second. So in this session, we are going to solve some of the questions which are very similar to your assignments problem and to which will help you to solve your assignments. So uh, So we are going to discuss all problems one by one. And if you have any doubt, any queries, you can unmute yourself and you can ask me in between. So let's get started with the first question. Okay. So please read the first question and first of all try to guess the answer by yourself and then I will discuss. So you can give your response in the polling section. So what I'm doing, I'm creating polls in the Google Meet. So there you can give your response. Okay, I can see the Sriram have given the answer. So Sriram, it will be better if you give your response in the polling section. You can find polling section in the Google Meet. There I will create the poll and there you can choose your options. Yes, I have launched the polls. You can find the options A, B, C, D there, and you can choose your options. I think uh, I think you are finding difficulty to find poll option in the Google Meet. So even if you find difficulty, then you can write in the chat. You can give your response in the chat box. After that, I will discuss the answer of this question with all of you. Any of you who is finding difficulty to understand what is being asked in the question? Apart from Sriram, others, can you please give your response either in the polling section or chat section? Okay, what I will do, I will start discussing the answer of this question. So you can see what is being asked. Which of the following is the most basic structural unit of the matter? So we know what is the matter. Matter is anything which occupies space and it has some mass. So that is the matter. So we can see what are the options are there. Atoms, crystal, element, molecule. Let's try to see what. Hello, Mant. Okay. So first of all, let's try to see. So what are all there? So if we see what is the atom, this is the schematic of an atom. We know atom is made up of some constituent. like electron, proton, neutron. It has nucleus. So this is the basic unit of any material. So all the material which we see around us, it is made up of atoms, and atom itself is made up of electron, proton, neutron. So yes, atom seems to be correct answer. Let's try to see others option also, why they will not be a suitable answer for this. So what is the crystal? So crystal, we see these are the some example of the diamond crystal. So uh, any solid object which is made up of a long range arrangement of these atoms. So basically what will happen, what is there inside this diamond crystal? So diamond crystal is also made up of carbon atoms, but carbon atoms are arranged in a very periodic manner. So if you see how inside the diamond crystal, they are arranged in this way, which is called diamond cubic. So here is the carbon atom, one carbon atom, and this pattern is keep on repeating for a long range. So those kind of solids where atoms are keep on repeating in periodic manner for the long range, those are called crystalline solid. Yes, but inside crystalline solids also, the basic unit is atom. These are atoms. So let's see what is the element. So element is nothing. It is the uh, it is the uh, it is the identity of different kind of material which is present on our earth. Uh, so let's say we have gold, copper. So all these are. Others can hear me apart from Shivam. Apart from Shivam, others can hear me or not? Hello, am I audible to all of you? Hello. Apart from Shivam, am I audible to others? Am I audible now?
Yes, sir.
Yes, sir.
Okay, actually I'm using two devices and I don't know, there is some issue with the other device. Okay. Okay, so uh, I was discussing about this question. Basically, I was discussing about all of these options. So atom, crystal, element, molecule. So I was discussing like that. Uh, Atom is the basic structural unit, but I was explaining what are others are there, like what is there inside the crystal, what is the element, what is the molecule, and why they are not the correct answer for this question. So so let's start looking them again one by one, since I was not audible to all of you. So atom, from the diagram we can see it is made up of electron, proton, neutron. So that we know from our uh, even from our 10th 11th class that atom is the basic unit, and it is also made up of some particles, electron, proton, neutrons. And what is the what crystal? Crystal is basically it is used for the solid objects, and in solid objects we know atoms are there are two types of solid object where it is amorphous and crystalline, and inside the crystalline solids these atoms are arranged in a periodic manner in repetitive pattern, and that kind of solids are called crystalline solids. To such an example we can see is the we can see the diamond crystals. uh, diamonds are look like this diagram which I have shown here. And inside this diamond crystal, what is there?
It is also
It is also made up of atoms, but here the thing is that
those
those atoms are arranged in a
very
very periodic manner, and that
the smallest
the smallest repeating unit
it shaped
like
this.
this.
This is called
diamond cubic structure.
So diamond
is made up of carbon atoms. These are carbon atoms.
And these are arranged
a very specific manner. So
this whole structure is keep on repeating in three dimensions. And that type of solid
is called crystal
or crystalline
solid.
And next option is
C.
So what is the
element?
Element is
nothing. It is
identity
identity of the different material which have unique properties. Like if we can see gold, silver, iron. All of them are different element, but again
they are
made up of same kind of atom.
If we
talk about gold, if we are
telling about
the gold, that
gold is
an element, it means
it is made up
of
lots
of gold atoms.
Only
pure gold atoms.
So that is
the element.
What happens in the
molecule?
So molecule
is also made up of atom. But here
it is a
combination of two or more
atoms. But here there is no restriction
that the atom should be of
same
type.
They
can be
different type
also. Like
if we talk
about the water,
it is made up of
hydrogen and oxygen.
So this is the
H2 molecule, water molecule.
So we can see apart from atom, other options are
itself.
They are made up of
atoms.
Crystal,
if we talk about,
it is also
made up of atoms.
Element is
also made up of atoms.
Molecule
is also made up of atoms.
Therefore,
the correct option is atom.
Okay.
Yes, sir.
Okay.
So
if you have any doubt in between, you can
unmute yourself
and you can
ask me.
Okay. So let's move to the
next question.
Is it visible
to all of you?
Is it visible? Can you see the
problem number 2?
Yes, sir.
Okay. What I will do,
I am creating a
poll in the
polling section.
There you can
give your answer.
Sriram has
given answer.
I am waiting
for others.
Okay. Yes, I would like
all of you to please give your response in the polling section, which you can find in the
Google Meet
polls option.
Yes, I will
Yes, I will create the polls
for the question
for the
number
question
2.
number 2.
You can find
You
it
can
in the
find it
polling
in the
section. You
polling
can
section. You
find
can
option
find
A,
option
B,
A,
C.
B, C.
You can
You
choose
can
your
choose
answer
your
there.
answer there.
Any of you
Any of you
who didn't
who
find
didn't
the
find
option
the option
option
of polling?
you can give your
You can
vote
give
in
your
the
vote
polling
in the
section.
polling section.
Yes, I have
Yes,
got
I
two
have got two
response.
response.
Others
Others
who are finding
who are
difficulty,
finding
they can
difficulty, they
unmute
can
and they can
unmute
ask.
and they
I
can
can
ask.
help.
I can help.
Okay, I think
Okay, I
all of
think all
comfortable
of
with the
comfortable
polling
with the
option.
polling option.
So,
So
I think
I think
everyone have
everyone
understood
have
what is
understood
being
what
asked
is
in the
being asked in
question.
the question.
So,
So
if any of you
if
have
any of
doubt,
you
I
have
can
doubt, I
explain the
can
question.
explain the question.
Otherwise,
Otherwise, I will
go and explain
go
the
and explain
solution of
the
this
solution
question.
of this question.
Okay.
Okay.
It seems
It
everyone is
seems everyone is
comfortable with the
comfortable
question.
with the question.
So,
So
it is being
it is
asked.
being asked.
Machining
Machining
is which of the
is which of
following
the following
process?
process?
So,
So
machining is
machining
also
is
a
also a
manufacturing
manufacturing
process,
process,
and
and
we are aware
we
of
are
that
aware
there
of
are
that there are
two different
two
kinds
different
of
kinds of
manufacturing
manufacturing
process.
process. So
One is the
one is the
primary and one
primary
is the
and one is the
secondary.
secondary.
If you have gone
If you
to
have
the
gone to the
course
post
lectures,
lectures,
there
there
sir has
sir
already
has already
explained well that
explained well that
primary
primary
process are
primary process
those
are those
where we
where
try to
we try to
achieve
achieve
the
the
shape or the
shape or the
dimension of the
dimension of the
component.
component.
So why we
So
are
why we are
manufacturing component?
manufacturing component?
We are trying to
We are trying
manufacture
to
the
manufacture the
component
component
in order
in
to
order to
increase
increase some value
it
so
could
that it
perform
could
some
perform some
function.
function.
And in
And
primary
in primary
manufacturing process,
manufacturing
we
process,
try
we
to
try to
achieve the
achieve
major
the
shape
major shape
of the
of the
component.
component.
So, what are the
So what are the
examples of
examples
primary
of primary
manufacturing process?
manufacturing process?
Can any of you
Can
tell?
any of you tell?
Casting,
Okay, yes,
Okay,
correct.
yes, correct.
Okay, apart
Okay,
from
apart
forging,
casting,
from casting,
yes,
yes,
forging,
yes,
yes, yes.
forging,
Forging,
or let's say
or let's
rolling.
say rolling.
Yes, these
Yes,
drilling,
are
these
the
are the
yes.
yes.
Someone,
Someone,
someone was saying
someone was
something.
saying something.
Okay.
Okay.
drilling
So
process.
No,
no,
drilling is not a
drilling is
primary
not a primary
process.
process.
So it is a
So it
part
is a
of the
part of the
machining. So it will
machining.
come
So it
under
will come
the
under the
secondary
secondary
process.
process.
So in
So in
secondary
secondary
process, we try
process,
to
we try
achieve
to achieve
the
the
dimensional
dimensional
accuracy.
accuracy.
So we try
So
to
we
reach the
try to reach the
tolerance, surface
tolerance,
finish.
surface finish.
So
So
these are
these
the
are the
secondary
secondary
operations.
operations.
So
So
machining.
machining.
So
So
machining
machining
is a
is a
secondary
secondary
process. So
process.
there are many
There are
processes
many
inside the
processes inside the
machining,
machining,
like
like
drilling,
drilling,
or let's say
or let's say
turning,
turning,
or let's say
or let's say
milling.
milling.
So these
So
are
these are
the
the
secondary process,
secondary
and
process, and
machining is
machining
also
is
there are two
also there
types,
are
like
two types like
conventional and
conventional and
non-conventional.
non-conventional.
So these are
So these are
the
the
examples of
examples
the
of the
conventional
conventional
machining.
machining.
So
So
what is
what
the
is the
difference
difference
in the
in the
machining
machining
and
and
other
other
processes?
processes?
So
So
let's take an
let's take
example.
an example.
What we do
What
in the
we do
casting
in the
process.
casting process.
So
So
we have
we
some
have some
scrap
scrap
materials like
materials
here.
like here.
Let's say
Let's say
these are
these
aluminum
are
scrap
aluminum scrap
or raw
or raw
aluminum,
aluminum,
and we want to
and we want to
manufacture
manufacture
some
some
let's say cuboidal
let's say
block
cuboidal
of
block
any
or
shape.
any shape.
So
So
What we do?
What we do?
We heat
We
it
heat it
and we melt
and we
them
melt
and
them and we try to
we try to put it inside a mold.
a mold.
So
So
we melt
we
it,
melt it,
and this
and
molten
this
material
molten
we
material
try to
we
put
try
in
to
the
put in the
mold,
mold,
and
and
we leave it for
we leave it for
solidification, and
solidification, and finally
we get
we
the
get the
component.
component.
So let's say this is the
This
final
is the
component
final
which we
component
get
which we get
after
after
casting.
casting.
But
But
when you see the
when you
casting
see the
product,
casting product,
their
their
surface
surface
as well as their
as well as their
dimensions are
dimensions are
not
not
very
very
accurate.
accurate.
So
So
you can
you
find
can
some
find
surface
some surface
roughness
roughness
or some
or some
projections.
projections.
So
So
it is
it is
we cannot
we
use the
cannot
casting
use the
product
casting
directly.
product directly.
So
So
what we have to
what we
do,
have to do,
this
this
this component
this
will go
component
for
will go for
the
the
machine.
machine,
And in
and in
machining,
machining
what
what we do,
we try to
we try to
remove
remove
extra
extra
material
material
which is
which
not
is not
desirable,
desirable,
and we remove
and
it
we
such a
remove it
way
such a way
so that after
so that
removing
after removing
extra
extra
material, we will
material we
get
will get
the
the
component with
component with good
good
surface
and
fees and
dimensional
dimensional
accuracy.
accuracy.
So
So
uh,
uh,
let's say this
let's say
component
this
will go
component
for
will go for
face milling,
face milling,
and after
and
that
after that
it will
it
go
will
for the
go for the
grinding,
grinding,
and finally
and
we get
finally we
a
get
pretty
a
neat and
very
clean
neat and clean
component
component
with good
with good
dimensional
dimensional
accuracy and
accuracy and
tolerance.
tolerance.
So
So
what we did,
what we did,
we
we
removed some extra
removed some extra
material
material
from the
from the
casted product.
casted product.
That's why the
That's why the
machining is the
machining is the
material
material
removal
removal
process.
process.
Whereas the other
Whereas the other
processes
process,
like
like
joining, we know
joining, we know
welding,
welding,
where we
where we
join two
join two
different
different
components,
components,
and
and
sometimes we need
sometimes we
some
need
filler
some
material.
filler
So
material.
their
So their
material addition
material
takes
addition
place.
takes place.
As well as if
As
we
well
talk
as if we
about
talk about
regenerative process,
regenerative process,
so one of the
so one
classic
of the
example is
classic
like
example is like
3D print.
3D printing.
Their
Their
material,
material
we try to
we
make
try to make a
component
component
by
by
depositing
depositing
the
the
material layer by
material layer by
layer.
layer.
So
So
this is
this
also
is also
addition process
addition
or
or
material
material
process,
addition process,
and it is
and
also
it is
material
also
addition
material
process.
addition process.
And
And
these are
these are
these options
these
are
options
not
are
correct
not
for
correct for
machining
machining
process.
process.
So
So
correct answer is
correct
the
answer is the
removal.
removal.
Okay.
Okay.
Yes, sir. Okay. Still
Okay.
any of you
Still
have
any
any
of you
doubt?
have any doubt?
Please,
Please
please unmute
please
yourself and you
unmute
can ask
yourself and
me.
you can ask me.
Okay.
Okay.
Okay. Let's move
Okay.
to the
Let's
next
move with the
question.
next question.
Okay. Please
Okay.
give the
Please give
question
the question
and
and
try to solve
try to
that by
solve
yourself,
by yourself,
and you can give your
and you can
response
give
in
your
the polling
response in the
section.
polling section.
After that, we
After
will
that,
discuss
we
it
will
together.
discuss it together.
Meanwhile, I will create
Meanwhile,
the
I will create
polls.
the polls.
Yes, I have
Yes,
launched
I
the
have launched the
polls.
polls.
Please read the
Please read the
question
question
carefully, and you
carefully,
can give
and
your
you can give
response
your
in the polling
response in the
section.
polling
After that,
section.
I will
After that,
discuss
I
it
will discuss
together,
it
all of you.
together, all of you.
Till now, I have
Till now, I
received two
have received
responses in
two
the
responses
polling
in the
section,
polling section,
so I am waiting
so
for
I am waiting
others.
for others.
Okay, Sri Ram.
Okay, Sri Ram.
Any of you
who
is finding difficulty to
difficulty to
understand
understand the question?
Yes, Vikram.
Yes, Vikram.
Anyone
Anyone
who cannot understand the
understand
question?
the question?
Okay.
Okay.
So what I will do,
I will
start
start
discussing
discussing the
solution
solution on this question.
So
So
let us see what is being asked in the
asked in the
question.
question.
Which of the
Which of the
following
following
statement is
true for
which is
which is
which of
which
following
of
statement
following
is true
statement is true corresponding to bonding
of solids?
of solids?
So
So
bonding of solid
bonding of
means
solid
what?
means what?
If we have
If we have two solids
and if we
and
try
if
to
we
make
try
a
to
bond
make a
between
bond
them,
between them, ultimately what we are doing?
We are
We are
creating
creating
bonds
bonds between the
atom of the
solids.
So
So
to make it, let's
let's
simplify this
simplify
problem
this
and
problem
let's
and
start
let's
looking.
start looking. Suppose
We have two
we have
atoms
two atoms
like this.
like this.
Okay, now they are
Now
kept
they are
far
kept
apart.
far apart.
What will happen?
What will happen?
We know
We know
any atom
any
is
atom
made up
is
of
made up of
nucleus
as well as
electrons revolving
electrons
around the
revolving around the
nucleus.
nucleus.
So here we
So
have
here we have
electrons
electrons
like this. And
and
nucleus is
nucleus is
positive charge
positive charge
electron,
electron,
it's negative
it's
charge.
negative charge.
So
So
there are
there are
different
different forces which will act
between
between
these
these
two atoms.
two atoms.
So
So
okay,
okay,
I will make this diagram
this
little more
diagram
clear.
little more clear.
Okay.
Okay.
For
For
simplicity, I am
simplicity, I am
taking
taking
one
one
electron.
electron.
So
So
these are
these
two
are
atoms,
two atoms,
atom 1
atom one
and this is
and this
atom
is
2.
atom two.
Atom 2
Atom
and
two
they
and
are
they are
distance r.
distance r. So
When this
when
atom
this
will
atom
see
will see
the atom
the atom
1 will see
one will
atom
see
2,
atom two,
what it feel?
what it feel?
It will feel
It will
two
feel two
of
kind of
forces.
forces.
Its
Its
nucleus is
nucleus is
positive charge,
positive charge,
so it
so
will
it will
feel
feel
attraction force
force between
between this
this
electron of the
electron of
other
the
atom,
other
as well
atom as
as
well as
the nucleus
the
of atom
nucleus
2
of
is also
atom 2 is also
positive charge.
positive charge.
It will
It will
feel
feel
a
a
repulsion
repulsion
force.
force.
Or
Or
here,
here,
because of
because
attraction
of
between
attraction
this
between this
nucleus and
nucleus and
electron,
electron,
there is a
there is a
attraction
attraction
force.
force. So,
But
but
the
the
magnitude of
magnitude
these
of these
forces
forces
are
are
a
a
function
function
of
of
distance
distance
r.
r.
So
So
let's
let's
try to
try to
see.
see.
So
So
I will
I
try
will
to
try to
plot the
plot the
force
force
as a
as a
function of
function
r
of r
between these two
between these two
atoms.
atoms.
Okay.
Okay.
On
On
y-axis we are
y-axis we are
showing the
showing the
force,
force,
and on
and on
x-axis we are
x-axis we are
showing the
showing the
distance
distance
between the
between
two
the two
atoms.
atoms.
I have
I have
drawn
drawn
three
three
curves.
curves.
So
So
this one is
this one
for
is
the
for the
repulsive
repulsive
force
force
between the two
between the
atoms.
two atoms. repulsive force.
And
This is attractive force.
And this is
the
sum of
both total force.
So when these atoms are far apart, so let's say
R is very high.
Then what
will happen?
If they are far apart, we will see the net force will reach to the this is a zero. Here we have negative forces, and here we have positive forces. Positive means repulsive.
Negative means attractive forces.
If
These
these two atoms
are
very
far,
then
then
they
won't feel any kind of force.
We can see
This
line.
This is the
Force
total
line.
force line.
It will tends to zero as if we keep on increasing the distance. So net force between them is
zero.
But what will happen? If we start bringing them together, then up to a certain
point,
I will
modify the diagram a little bit.
Force will something like this. So there will be some attractive force. If we start reducing the distance between those two atoms, so there will be attractive force between them. So after a certain point, let's say this is the R0. This is the point where the force between these two atoms will become equal. So mathematically, if I will try to show you, so use the total energy between these two atoms. So this is the empirical formula, or scientists have experimented, and they have found this kind of formula fits between the different kind of pairs of atoms. So there are two terms here. One is negative, one is positive. So negative one is for attraction. And this positive one is for repulsion. Since this is the energy equation, if we differentiate it, we will get the force equation. So differentiate it, we will find it. So we'll get this equation. Again, it has two terms. So one is for the repulsion, and one is for the attraction. And usually what happens, M is less than N. And because of this, when the R is greater than R0, there is a net attractive force between these two atoms. Attraction. And if R is less than R0, we can see the net force is going to be positive. Positive means repulsion. So at the point R0, at the distance of R0, there is an equilibrium. Attractive force equals to repulsive force. And that is the bond length. That distance is called the bond length. Now after understanding this, we can answer this question. So first option is attractive force results between two nuclei. No. since
since
both nuclei are
positive charge, so
there is
there
repulsion
is
force
repulsion
between them,
force
so it
between
is
them,
not
so it
correct.
is not correct.
And
Second option is the repulsive force
between
agent between
two
two
atoms.
atoms.
So
So
between
between two atoms,
which force will
which
work?
force will work?
Basically, both
Basically,
forces are
both forces
working,
are working,
but which one
but
is
which one
dominant?
is
It will
dominant?
totally
It will
depend
totally
on the
depend on the what is the
between
distance
them.
between them.
So
So
this
this option is
not
not
accurate.
accurate.
And third option,
And third option, if we see repulsive force
increases with
increases
decrease
with
in
decrease in
distance
distance
between
between
two
two
entities.
entities.
Yes,
Yes,
this is true.
this is true.
We can see
We
this is
can
the
see this
graph
is the
of the
graph of the
repulsive
repulsive
force.
force.
And we can
And
see
we
if we
can
keep
see
on
if we keep
decreasing
on
the
decreasing
distance,
the distance,
this
this
repulsive force
repulsive force
will keep
will
on
keep on
increasing.
increasing.
So this
So
is
this
the
is the
correct answer,
correct
and
answer, and
many of you
many of you
have
have
got the correct
got the
answer.
correct answer.
Since
Since
only
only
C option is
C
correct,
option is
so
correct, so
D is
D is
wrong.
wrong.
So
So
any of you
any
have
of you
still doubt
have
in this
still doubt
question?
in this question?
Is it
Is
clear
it
to all of
clear
you,
to all
or
of you, or
still there is
still there is some
some confusion?
confusion?
Sir, it's clear.
Okay,
Okay,
okay.
okay.
Even if later
Even
you
if
find
later
any
you find
difficulty,
any
you can
difficulty,
ask
you
me.
can ask me.
Okay.
Okay.
So now
So
we will
now
move
we
to
will
the
move
next
to the
problem.
next problem.
Please read the
Please read the
problem
problem
and try
and
to
time
find the
to
correct
find the
answer.
correct answer,
And you can
and
give your
you can
answer in
give
the
your
polling
answer in the
section.
polling section.
Meanwhile, I will
Meanwhile,
create
I
the
will
poll.
create the polls.
I have
I
launched the
have launched
poll.
the poll.
You can
You
find.
can find.
You can give your
You can give your
response in the polling
response in the
section.
polling section.
So
So
I'm waiting
I'm
for
waiting
the.
for the.
I'm waiting for your
I'm waiting for your
responses.
responses.
Please read the
Please read the
question.
question.
Please
Please
read the
read the
question
question
thoroughly.
thoroughly.
Till now, I
Till
have
now, I
received
have
one
received
response
one
only. I
response
am waiting
only.
for
I am waiting
others.
for others.
Anyone
Anyone
who is finding
who is
difficulty
finding
to
difficulty
understand
to
the
understand
problem?
the problem?
Okay,
Okay,
Sriram
Sriram
have given
have
answer
given
C.
answer C.
Okay,
Okay,
many of you
many
have
of you
given
have
your
given your
response in the
response in the
polling
polling
section.
section.
Okay,
Okay,
let's start
let's start
discussing the
discussing the
solution of this
solution of
problem.
this problem.
The
The
problem is,
problem is
which
which
of the
of the
following
following
is
is
not?
not.
Please
Please
please note down
please
the
note
word
down the word
not.
not.
True for true
True
corresponding to the van der
corresponding to
Waals
the van der Waals
forces.
forces.
So
So
what is
what
the
is the
main difference
main difference
between the
between the
van der Waals
van der
forces
Waals forces
and other
and other
bonding
bonding
forces?
forces?
So main
So
difference
main
is
difference
the
is
van der
the van
Waals
der Waals
force
force
acts on
acts
the
on the
molecule,
molecule,
whereas the
whereas
other
the
bonding
other bonding
forces
forces
is because
is
of the
because of the
electrostatic
electrostatic
forces between
forces
the
between the
atoms.
atoms.
So
So
there are
there are
situations
situations
where we
where
have
we have
molecules,
molecules,
where we have
where we have
two
two
molecules or
molecules
more
or
than two
more than two
molecules.
molecules.
So
So
because of the nature of the atoms involved in forming the molecules. The molecule gets some polarization. For example, if we
If we
if we have
if we have
earlier we have neutral atoms
when
when
they
they combine
combine
to
to
form
form
the
the
molecules.
molecules,
After
after
combining
combining
if you see the
if we
overall
see the overall
molecule,
molecule,
it has
it
some
has some
polarization.
polarization.
So
So
earlier they were
earlier they were
neutral, but
neutral, but
after forming the
after forming the
molecule
molecule
or
or
due to some
due to some
other
other
interactions,
interactions,
the
the
molecules get
molecules get
polarized.
polarized.
So
So
after
suppose after
polarization,
polarization,
there is a
there is a
charge
charge
distribution something
distribution,
like
something
this
like this
inside the
inside the
molecule.
molecule.
And because
And
of
because of
these
this
local
local
polarization,
polarization,
there is
there
a
is a
force
force
between
between
the two
the two
molecules.
molecules.
Here it
Here
is
it
negative, it
is
is
negative,
positive.
it
So
is
there is
positive,
a
so there is a
weak
weak
attraction
attraction
force
force
between
between
these two
these two
molecules will be there.
molecules will be there.
And these
And
kind of
these kind of
interactions are called
interactions are called
van der Waal
van der Waal
forces.
forces.
So
So
if you see
if we see
example,
example,
like we
like
have
we
H2O
have H2O
molecule.
molecule,
H2O is made
H2O
up
is
of
made up of
three,
three, sorry, it is made up of three atoms. This is the oxygen atom,
and this is
and
the
this is the
hydrogen atom. This
hydrogen
is
atom. This
hydrogen
is
atom.
hydrogen atom.
Since oxygen
Since
is
oxygen
more
is more
electronegative, what
electronegative,
it will
what
do?
it will do?
It will
It will
try to
try to
attract the
attract the
electrons
electrons
towards
towards
itself,
itself,
and
and
because of
because
this,
of this,
it will
it
gain
will gain
partial
partial
negative charge,
negative
whereas
charge,
the
whereas the hydrogen atoms will get
partially
partially
positive charge.
positive charge.
And
And
this is
this
the
is the
1s2
1s2
molecules.
molecules.
Similarly, if we
Similarly,
have
if we have
another H2O
another H2O
molecule
molecules
near
near
nearby
nearby
vicinity,
vicinity,
then
then
it will also
it
have
will also
similar
have
kind
similar
of
kind of
configuration.
configuration.
So there is
So
a
there is a
attraction
attraction
between
between
this
this
delta positive
delta
and delta
positive and
negative
delta
charge.
negative charge.
So there is an
So there
attraction
is a
between
attraction
hydrogen
between
and
hydrogen
oxygen
and
atom,
oxygen atom,
and
and
there this
there
kind of
this
interaction
kind
is
of
called
interaction
the
is called the
van der Waal
van der Waal
forces.
forces.
So
So
now
now
understanding this,
understanding
let's start
this,
to
let's try
see
to see
this
this
problem.
problem.
These are the
These are the
intermolecular
intermolecular
forces. Yes, it
forces.
is
Yes, it
correct.
is correct.
Second option is
Second option is
the
the
forces are
forces are
proportional to d to
proportional
the
to d to
power
the power
4.
4.
No, actually
No,
they are
actually they are
inversely
inversely
proportional to the d
proportional
to
to
the
the d
power
to the
4.
power 4.
So
So
it is
it
not
is not
correct.
correct.
So
So
in spite of
in spite of in spite
proportional, it should
proportion, it
be
should be
inversely
inversely
proportional. Then it would
proportional. Then
have
it
been
would have
correct.
been
Otherwise,
correct.
it is
Otherwise, it
wrong.
is wrong.
And now
And
next
now
one is
next one is the
these
these
are
are
the
the
weaker
weaker than
than
other
other
bonding
bonding forces.
forces.
Yes,
Yes,
there are certain
there are
bonding
certain bonding
forces.
forces.
We are knowing
We
that
are knowing that
covalent
covalent
bonds or
bonds
ionic
or
bonds.
ionic bonds.
So
So
this is the
this is the
weaker.
weaker.
It happens
It
because
happens
of
because
the
of the
bonding
bonding
happens because of
happens
the
because of the
partial
partial
polarization.
polarization.
Whereas if
Whereas
you see
if you
ionic
see
bonding,
ionic
there the
bonding, there the
transfer of
transfer of
electrons
electrons
happens. If you
happens.
see
If you see
covalent bonding,
covalent
their
bonding,
sharing
their
of
sharing
electrons
of
takes
electrons
place.
takes place.
So
So
those are the
those
very
are the
strong
very
bond.
strong bond.
And
And
because of
because of the
they are
they
having the
are having a
weak
weak
magnitude of forces
magnitude of
between
forces
them.
between them.
That's why
That's why
the
the
materials which
materials
have
which have
higher van der
higher
Waals
van der
forces,
Waal
their
forces,
melting
their
point
melting
is low.
point is low.
Whereas the
Whereas
ionic
the ionic
materials or
materials
covalent
or covalent
materials,
materials,
those are
those
having
are
higher
having higher
melting
melting
points.
points.
So these
So
are the
these are
weaker
the
than
weaker than
other bonding
other
forces. This
bonding
is
forces.
correct.
This is correct.
And these
And
forces
these
are
forces are
attributed to
attributed to
rapidly
rapidly
fluctuating dipole
fluctuating dipole
moments.
moments.
Yes, it is
Yes, it
correct.
is
I
correct.
told
I
that
told that
it
it
happens because
happens
of
because
the
of the
polarization of
polarization of
the
the
molecules,
molecules,
and because of
and
the
because of the
polarization,
polarization,
dipoles are
dipoles on
dipoles are keep
dipoles
on
are keep on
forming
forming
and
and because of that there is a van der Waals interactions takes place between the dipoles. So this is also correct. So if you see the question, since we have been asked which of following is not true, so this is the correct answer.
So is it
Clear to everyone?
Yes, sir.
Okay.
Okay.
If any of you
If
have
any of you
doubt,
have
please
doubt,
unmute
please
yourself.
unmute
You can
yourself.
ask me.
You can ask me.
Okay.
Okay.
It seems
it
it is
seems
clear
it
to
is clear
everyone.
to everyone.
So
So
let's move to
let's
the
move
next
to the
problem.
next problem.
Please read
Please
the
read the
question,
question,
and
and
again you can
again
give your
you can give
response
your
in the
response
polling
in the
section.
polling section.
Meanwhile, I will
Meanwhile, I
create the
will
polls.
create the
After
polls.
that,
After that,
I will
I
discuss
will
the
discuss
solution
the
of this
solution
problem.
of this problem.
Yes.
Yes,
I have launched
I
the
have launched
polls.
the polls.
You can give your
You can give
response
your
in the
response
polling
in the
section.
polling section.
Any of you
Any of
have
you have
any doubts,
any doubts, please
ask me. Please don't
Please
hesitate.
don't hesitate.
This session
This
is
session is
mainly for the
mainly
doubts
for the doubts
discussion and
discussion
problem
and
solving.
problem
So
solving.
please
So
feel
please
free
feel
to
free
ask
to
any
ask
questions.
any questions.
Till now, I
Till
have
now, I
received the
have
three
received the three
response in the polling
response in the
section.
polling section.
So
So
I am waiting
I
for
am waiting for
others.
others.
Okay, I will wait
Okay, I
for
will wait for
one more
one
minute.
more minute.
Then I will
Then
discuss.
I will discuss.
Okay,
Okay,
let's start
let's start
discussing
discussing
the
the
solution of this
solution of
question.
this question.
So it has been
So it has
asked,
been asked,
how many
how
number
many
of
number of
atoms
atoms
are
are
present per
present
unit
per
cell
unit
in
cell
case
in
of
case of
BCC crystal
BCC
structure
crystal
or
structure or
body center
body
cubic
center
crystal
cubic
structure.
crystal structure.
So,
So,
if you can
if you
recall
can
the shape
recall
of
the shape
BCC
of BCC
structure,
structure,
so it will
so it will
look something
look
like
something
this.
like this.
So
So,
it is the
it is
unit
the
cell
unit cell
which have been
which have
shown
been
in the
shown in
diagram.
the diagram.
So this is the
So, this
hard
is a
spear
hard
model.
spear model.
Hard spear
Hard spear
model.
model.
And this is
And
the
this is the
unit cell
unit
model.
cell model.
So
So,
BCC
so
is
BCC
nothing.
is nothing.
It is
It
the
is the
cubic unit
cubic
cell,
unit cell,
and we know
and
unit cell is
unit cell
the
is the
smallest
smallest
repeating
repeating
unit
unit
of any
of
crystalline
any
solid.
crystalline solid.
That is called
That is
the
called the
unit cell.
unit cell.
So
So,
inside
inside
this unit
this
cell,
unit cell,
so it is
so
cubic
it is
in
cubic
shape.
in shape.
That's why in the
That's
name
why
is
the
given
name is given
body
body
central
central
cubic.
cubic.
So
So,
if you see,
if you
there
see,
are
there are
total
total
1,
one,
2,
two,
3,
three,
4,
four,
5,
five,
6,
six,
7,
seven,
8, and
eight, and
9 atoms.
nine atoms.
So
So
we can see
we can see
there
there
are
are
nine atoms.
nine items
We need
we
to
need to
show in order
show
to
in order to
represent a
represent a
BCC
crystal
crystal structure.
but
But
all of
all of
these
these
atoms
atoms
are
are
not
not
contributing
contributing
for
for
this unit
this
cell.
unit cell.
So
So
only if
only
you
if you
see
see
if you see this
if you see this
diagram,
diagram,
we can
we
clearly
can
see
clearly see
there is a
there is a
central
central
atom which
atom
is
which is
completely
completely
inside
inside
this cube.
this cube.
Apart from
Apart
that,
from that,
there are
there are
other eight
other eight
spheres
spheres
whose one
whose
by
1/8
eighth part is
part is
coming
coming
inside this
inside this
cube.
cube.
So
So
eight corner
eight corner
atoms are
atoms are
contributing
contributing
one by
1 by
eight.
8.
So the
So the
total number
total
of
number of
corner atoms
corner
are
atoms
eight.
are 8.
It will
It
become
will become
one.
1.
And
And
since this
since
central
this
atom is
center atom
completely
is
inside the
completely
unit
inside the
cell,
unit cell,
so this is
so this is
another
another
atom.
atom.
So if
So
we
if
talk
we
about the
talk
unit
about a unit
cell
cell
inside the
inside the
BCC crystal
BCC crystal
structure,
structure,
so there will
so
be
there will
total
be total
two atoms.
two atoms.
So
So
total number
total
of atoms
number of
present
atoms
inside the
present inside
BCC
the
crystal,
BCC crystal,
it will be
it
1
will be
plus
1
1,
plus 1,
2.
2.
And the correct
And the
answer
correct
is
answer is
A.
A.
So
So
most of you have
most of you have
got the correct
got the
answer.
correct answer.
So
So
if still any
if
of you
still
have
any of
any
you have
doubt,
any doubt,
please let me know.
please let me know.
Similarly, you
Similarly,
can also
you can
think
also
of
think of
hexagonal glow
hexagonal
stacking
glow
crystal
stacking
or
crystal or
FCC crystal,
FCC crystal,
face-centered
face
cubic
centered
structure.
cubic structure.
So that
So
you
that
can do by
you can
your
do by
own.
your
But
own.
still,
But
if you
still, if you
find any
find
difficulty,
any
please
difficulty,
let me know.
please let me know.
Okay.
Okay.
So
So
if
if
any of you have
any
no
of you
doubt in
have
this
no doubt in
question,
this question,
so let's
so
quickly
let's
move
quickly
with
move with
next problem.
next problem.
Please
Please
read the
read the
question and try
question and
to
try
give
to
the
give
answer.
the answer.
Meanwhile, I will
Meanwhile, I
create
will
the poll.
create the
You can
poll.
keep
You can
your
keep
answer
your
in the
answer
polling
in the
section.
polling section.
Yes, I have
Yes,
launched
I
the
have launched the
polls. I
polls.
can see
I
there
can
are
see
two
there are two
response
response
in the chat
in
box
the chat
also.
box also.
I will
I will
request
request
everyone
everyone
to give your
to give
response
your
in the
response
polling
in the
section so
polling
that
section so that
other people
other
can try
people can try
independently.
independently.
Okay.
Okay.
Let's start
Let's
discussing
start
this
discussing
question.
this question.
So
So
what has been
what
asked? It
has
has
been
been
asked? It
asked
has been
that
asked
if
that
the
if the
radius of
radius of
an atom
an
in
atom in
closed
closed
packed
pack
hexagonal crystal
hexagonal
is
crystal
R.
is R.
The length
The
of
length
edge of
of edge
unit
of
cell
unit cell
A is.
A is.
So
So
since here
since
I
here
have
I
already
have
shown
already
few of the
shown few of the
diagrams.
diagrams.
So
So
hexagonal
hexagonal
closed
closed
pack
pack
structure looks
structure looks
something
something
like
like
these.
these.
So
So
uh,
uh,
if I
if
will
I will
try to
try
locate
to
what are
locate what are
the
the
lattice
lattice
constants
constants
or
or
length of
length
the
of the
edges
edges
of
of
the
the
hexagonal
hexagonal
crystal.
crystal.
So
So
we are
we
denoting
are
it by
denoting it by
A.
A.
This is
This is
also
also
A.
A.
Similarly,
Similarly,
all the
all the
sides of
sides
the
of the
hexagonal
hexagonal
structure
structures
is
is
mostly
mostly
represented by
represented by
the letter
the
A,
letter A.
and
And
this
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 dimension
dimension usually shown by letter C. So
here
here it has been asked
if
if
all the
all the
with all
at
the
all the
corners
corners
of the
of the hexagonal closed
pack
pack
structure,
structure, if we are
keeping
keeping
atoms,
atoms,
what is the
what
atom?
is the atom?
What is the
What
dimension
is the
of the
dimension of
atom?
the atom?
So we
So
are
we are
keeping the
keeping the
atoms of
atoms of
radius r.
radius r.
Okay,
Okay,
and now
and now
what has been
what has
asked?
been asked?
If
If
if the
if
radius
the
of
radius of
atoms is
atoms
r,
is
then what
r,
would
then
be
what
the
would be the
edge length
edge
of the
length of
unit
the unit
of the
of the
closed
hexagonal
pack
closed pack
unit cell?
unit cell?
So
So
if we
if
see
we see
in
in
reality
reality molecules,
sorry, atoms are
atoms
arranged
are
in
arranged in
this manner.
this manner.
So
So
six atoms
six
are
atoms are
these are the
these are
six
the
atoms.
six
These are
atoms. These are
surrounding one
surrounding
central
one
atom.
central atom.
Similarly,
Similarly,
bottom one
bottom one
also.
also.
In between
In
there are
between there are
three atoms.
three atoms.
If we
If we
take cross
take cross
section
section
and if we
and if we cut it
in the
in the
hexagon,
cut it in the shape of the
closed
hexagonal
packing
closed
unit
packing
cell,
unit cell,
then it will
then
look
it will
something
look
like
something
this.
like this.
As I told,
As I told,
this is
this is
the
the
radius
radius
of the
of the
atom
atom
is r.
is r.
If you see
If you
this
see
edge,
this edge,
we
we
focus on this
focus on
edge.
this edge.
This is
This is
nothing but
nothing but
a. And if you
and
see
if you see
these
these
two
two
atoms are
atoms are
touching
touching
each other,
each other,
and we know
and
the
we
radius
know
of
the
these
radius
two
of
atoms
these
is
two atoms
r.
is r.
So if
So
we add
if
these
we
two
add these two
distances,
distances, then we
come to
will
know what
come
is
to know
the
what is the
length of
length
edge.
of edge.
So we can
So we
clearly
can
see
clearly
A is
see A
equals
is
to
equals to
2r.
2r.
So the
So
correct answer
the
is
correct answer is
C.
C.
So it was
So
simple
it was
question.
simple question.
So
So
still, if any of
still,
you
if
have
any
any
of you have any
doubt, please let me
doubt,
know.
please let me
Otherwise,
know.
we will
Otherwise, we will
move to the next
move to the
problem.
next problem.
Okay, it
Okay,
seems there
it
is
seems there is
no doubt.
no
So
doubt.
let's
So
move to
let's
the
move to the
next problem.
next problem.
Which of the
Which of the
following
following
is a
is a
surface
surface
finishing
finishing
process?
process?
Okay, I am
Okay, I
creating the
am
polls.
creating the polls.
Please give your
Please
answer
give your
in the
answer
polling
in the
section
polling
only.
section only.
I have launched
I
the
have launched the
polls.
polls.
You can give your
You can give your
response in the polling
response in the
section.
polling section.
Okay.
Okay.
I have got
I have got
responses,
responses, and
and most of you have
most
got
of
the
you have
correct
got the
answer.
correct answer.
So,
So,
which of the
which
following
of the
is the
following is the
surface finishing
surface finishing
process?
process?
So, as I
So, as
told
I
earlier,
told
that the
earlier, that the
surface
surface
finishing
finishing
surface finishing
surface finishing
process,
process,
they have
they have
objective
objective
to
to
make
to make
the
the
good surface
good
finish
surface
of the
finish of the
component.
component.
So
So,
we know
we know
what is the
what is
casting.
the
Casting
casting.
is the
Casting is
primary
the primary
process,
process,
and in
and in
casting we
casting we
achieve the
achieve the
shape.
shape.
We achieve
We
the
achieve
final
the final
shape
shape
and
and
size,
size,
but
but
we can't
we
achieve
can't
the
achieve
good
the good
dimensional
dimensional
accuracy
accuracy and
Yes, Shivam,
You probably
you
get the
probably
whole
get the whole
recording of this
recording
session.
of this session.
Okay.
Okay.
So
So
after getting
after
the
getting
overall
the
shape
overall shape
and
and
dimensions,
dimensions,
the
the
component
component
goes for the
goes for the
machining operations
machining
like
operations like
turning,
turning,
milling,
milling,
shaping.
shaping.
But
But
still,
still,
after these
after these
operations,
operations,
we
we
we cannot
we
achieve
cannot
a very
achieve a
good
very
surface
good
finish
surface finish
because of
because
the
of the
feed marks
feed
of
marks
the
of
cutting
the cutting
tools.
tools.
So
So
there are
there are
waviness
waviness
and
and
we cannot
we
find the good
cannot find the good
surface roughness
surface roughness
values.
values.
So
So
if we
if we
typically talk
typically
about
talk about
the
the
surface roughness
surface roughness
values after
values after
machining process
machining
we will
process
get,
we will get,
it
it
remains
remains
within the
within
range of
the
the
range of the
millimeters.
millimeters.
But
But
for the
for the
proper
proper
functioning of
functioning
the
of the
most
most
of
of
the
the
component,
component,
we
we
desire to
desire
achieve
to achieve
the
the surface
surface
finish
values
values
in the
in the
microns.
microns.
For this,
For this,
for
for
for that we
for
have
that
to
we
go
have
for
to go
the
for the
surface finishing
surface finishing
operations,
operations,
and one of
and one of
those
those
operations is the
operations is the
grinding.
grinding.
Apart from
Apart
grinding,
from
what
grinding,
are other
what are other
surface finishing
surface
operations?
finishing
Can
operations? Can any of you
please tell?
can please tell?
Apart from
Apart from
grinding, any other
grinding, any other
examples of
examples of
surface finishing
surface finishing
operations?
operations?
Okay.
Okay.
So apart
So
from
apart from
grinding, we
grinding,
have
we have
lapping,
lapping,
honing,
honing,
polishing,
polishing,
buffing.
buffing.
So
So
all of have
all of
their
have
all
their all
capabilities.
capabilities.
So
So
depending upon
depending
the
upon the
required
required
accuracy,
accuracy,
we go
we
for the
go for the
different
different
surface finishing
surface finishing
operations.
operations.
So
So
yes,
yes,
grinding is the
grinding is the
correct answer,
correct
but
answer, but
I will
I will
quickly try to
quickly
show
try
what
to show
happens in
what
the
happens in the
grinding.
grinding.
So
So
in
in
grinding,
grinding,
what we
what
have,
we have,
we
we
have
have
rotating
rotating
tool.
tool.
So
So
let's say
let's
this
say
is
this
a
is a
grinding tool.
grinding tool.
I will
I
try
will
to
try
make
to
it.
make it.
Or it is
Or
a
it is a
grinding wheel.
grinding wheel.
It
It
is
is
rotating, let's say,
rotating,
the
let's say, the
speed
speed
of
of
omega.
omega.
And what
And what
on the
on
surface
the
of the
surface of the
grinding wheel,
grinding wheel,
small
small
abrasives are
abrasives are
sticked,
sticked,
or
or
grinding wheel
grinding
itself
wheel
is made
itself
up
is
of
made up of
different
different
abrasives like
abrasives like
alumina
alumina
or cubic
or
boron
cubic boron
nitride. So
nitride.
there are
So there
many
are many
abrasives which you
abrasives
will
which you
study
will
later in
study
this
later in
course.
this course.
So they are
So
stick
they are
together with
stick
the
together
help
with
of
the
some
help of
bonding
some
agent.
bonding agent.
So
So
this
this
keep
is
on
keep on
rotating.
rotating.
And suppose
And
if we try
suppose
to
if we try
improve
to
the
improve the
surface finish of
surface
this
finish of this
component, what we
component,
will
what
do?
we will do?
We will
We
bring
will
this
bring this
component
component
like
here
and
and
we'll
will
move
move
this
this
grinding wheel
grinding wheel
over
over
this
over this
surface
surface
one by one,
one by
one by
one, one
one.
by
After
one.
many
After many
passes,
passes,
we can
we can
see
see
the surface
the
finish
surface
of
finish
this
of this
component
component
will get
will get
improved.
improved.
So
So
what we did
what
here,
we did here,
we
we
we remove
we remove
a
a
small layer
small
of the
layer of the
material
material
with the help
with
of
the help of
this
this
grinding
grinding
wheel.
wheel.
Grinding
Grinding
wheel.
wheel.
So
So
since it has
since it has
abrasive
abrasive
particles,
particles,
they
they
remove
remove
materials from
from
the
the top
surface
surface
of the
of the
component
component
which we have got
which we have
from the
got from the
casting or
casting
other
or
family
other family
processes,
processes,
and
and
it
it
remove
remove
the
the
materials in the
materials in the
form of
form of
small
small
chips.
chips.
And after
And after
removing
removing
the
the
a layer of
layer of
material,
material,
the surface
the
we will
surface
get,
we will get,
it has
it
very
has
good
very good
surface finish.
surface finish.
So this
So
is the
this is
grinding
the
process.
grinding process.
Apart from
Apart
this
from this
lapping, honing,
lapping, honing,
polishing,
polishing,
there are
there
also
are also
surface finishing
surface finishing
processes.
processes.
So if you see the question, the grinding is the correct option, whereas other options like casting, it is the primary process. There we won't get good surface finish. Similarly, rolling is also primary process. Rolling is mainly used for getting the sheet-like material, or we try to get the different other shapes which have constant cross-sectional area, whereas the welding it is used for joining two different components. So correct answer is the grinding. So still, if any of you have any doubt, please let me know. Otherwise, we will move to the
Next question.
next question.
Okay.
Okay.
Please
Please read the question
and try to
and
give
try
your
to
answer
give your answer
in the polling
section.
Meanwhile,
Meanwhile, I will create the polls. After that, I will discuss.
Oh, Vikram.
Oh, Vikram.
Yeah.
Yeah.
Uses of rolling.
Uses of rolling.
Vikram, one of the
Vikram,
good
one of the
example,
good
if I can
example,
tell
if I can tell
you,
you,
can you think
can
of
you think of how
tracks of
tracks of the rails
are made?
are made?
Okay.
Okay.
I will show
I will
here.
show here.
I will quickly
I will
tell
quickly
how
tell how railway tracks are made, or
any
any
sheet components
sheet
are made.
components are made.
So
So
you know,
you know,
you can
you
see
can
how
see
the cross
how the
section
cross
of the
section
railway
of the
tracks
railway
look like.
tracks look like.
It is
It is
something
something like
like this
this
I
I
section.
section.
Okay.
Okay.
So
So
if you
if you
see,
see,
it will look
it will
something
look
like
something like
railway tracks.
railway tracks.
But do you
But
know
do you
how it
know
is
how
made?
it is made?
From if you see
From
the
if you see
starting
the starting
material,
material,
starting
starting
material.
material.
So
So
initially
initially we will what
we have
we have
iron ore.
iron ore.
Iron ore.
Iron ore. So it
Like
looks
soil.
like soil.
Typically, it looks
Typically
like
it looks like
soil.
soil.
So what we
So
do?
what we do,
We
we
this iron
this
ore
iron ore
goes in the
goes
steel
in the steel
industry,
industry,
and there
and there
inside the
inside
blast
the blast
furnace,
furnace
we try
we
to
try to
extract
extract
the
the
iron,
iron,
wrought
wrought iron,
and
and
what we do?
what we
We
do, we
heat
heat
these
these
ores,
ores,
and finally
and
we
finally
get
we get
iron in the
iron in
molten
the
form.
molten form.
Apart from
Apart
pure
from
iron,
pure
we also
iron, we
get
also get
some
some
impurities material,
impurities materials,
slag and
slag
flux.
and flux.
Those things we
Those things we
remove.
remove.
Finally,
Finally,
we get
we get
molten
molten
iron
iron
from the iron
from the
ore.
iron ore.
And
And
okay, let me change the
let me
color.
change the color.
And
And
what we do?
what we do,
We try
we
to
try to
make
make component
very
very
simple shape
simple shape
from this
from
molten
this
iron.
molten iron.
So
So
they are
they
just
are
a
just a
simple
simple
rod of
rod
long
of long
cross section.
cross section.
So they are
So
called
they are
billets.
called billets.
And
And
apart from
apart
this,
from this,
we
we
also try
also
to
try
make
to make
slab
slab
like
like
shapes.
shapes.
Okay,
Okay,
I will try to
I
make
will
the
try to
slab
make the
here.
slab here.
Slabs look like
Slabs look like
this.
this.
Okay.
Okay.
So
So
after
after
uh,
after
casting,
casting,
we get
we get
either
either
billets
billets
or let's
or
say
let's
slab.
say slab.
And from
And
these
from these
billets,
billets,
what
what
how
how
we
we
we have to
we have to
make
make
this
this
railway track
railway track,
that is
that
in the
is
shape
in the
of
shape of
I
I
section.
section.
So
So
this
this
process is
process
done
is
by
done by
rolling.
rolling.
So
So
if you
if you
if I will try
if
to
I will
show
try to
quickly
show
how
quickly
the rolling
how the rolling
look like.
look like.
Okay,
Okay,
let's remove
let's
something.
remove something.
We take
We
this.
take this.
We take
We
this
take this
billet.
billet.
Okay.
Okay.
We took
We
we
took
took this
we took
billet
this billet
and
and
we heat
we
it
heat
and
it
we
and we
try
try
pass it in between two rollers.
So
So
earlier
earlier
billet was like
this,
and now
and now
what I did,
what I did,
I tried
I
to
tried to
pass
pass
this
this
billet
billet
through the
through the
between the gaps of the roller.
Meanwhile, I will
Meanwhile, I
apply
will apply
some
some
compressive
compressive
forces.
forces. And
And
what is
what
the
is
unique
the
about
unique
this?
about
The
this? The
counter shape
counter
of this
shape of
roller,
this roller,
it was
it was
something like
something like
I check
I
set.
check set.
Okay.
Okay.
So
So
one by
one
one,
by one,
after
after
after one
after one
pass,
pass,
this
this
square cross
square cross
section
section
will get convert like
convert like
this.
this
After one
after
pass,
one pass.
when I
Again,
will
when I will
pass
pass
through the
through the
different set of
different set of
rollers,
rollers,
it will
it will
little bit
little bit
more come
more
into the
come
cross
into the
section
cross
of the
section of the
I beam.
I beam.
And after
And
let's say
after, let's say
10
10
passes,
passes,
we
finally
get
we get
exact
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 shape of the
shape
railway
of the
track.
railway track.
But what
But
happens
what
there?
happens there?
This shape
This shape
changes
changes
from
from
square or
square
rectangular
or
cross
rectangular
section
cross
to
section to
I cross
I
section.
cross section.
I cross
I
section.
cross section.
And the
And the
length of
length
this
of
billet
this billet
increases
increases
multiple
multiple
times.
times.
Earlier
It
if it
was,
was
if it
let's
is was,
say
let's say
10 meter,
10 meter,
after rolling it
after
will
rolling it
become
will become
50 meters.
50 meters.
These are roughly
These are roughly,
these are
these are
rough numbers
rough
just
numbers,
to make you
just
feel.
to make you feel.
So this is the
So
one of
this is the
the
one of the
application of the rolling
application of the
process.
rolling process.
Apart from
Apart
these,
from these,
you know, sheets,
sheets,
how our
how our
car
car
or
or
how cars are
how
made.
cars
This
are
is
made.
mainly
This
made
is
up of
mainly made up of
metallic sheets,
metallic
and
sheets,
those
and
sheets are
those
made up
sheets are
of
made up of
made by the
made
rolling
by the
process.
rolling process.
Okay,
Okay,
so let's
so
move
let's
to the next
move to the
problem.
next problem.
Please
Please
read the
read the
problem
problem
and try to give
and try
your
to give your
answer in the polling
answer in the
section.
polling section.
So meanwhile, I
So
will
meanwhile,
create
I
the
will create the
polls.
polls.
I have launched
I
the
have launched the
polls.
polls.
Please give your
Please give
response
your
in the
response
polling
in the
section.
polling section.
If any of
If
you
any
still
of
have
you
any
still
doubt,
have any
please
doubt,
let
please
me know.
let me know.
I'm waiting for
I'm waiting for
response of
response
other
of other
people's.
people's.
Okay,
Okay,
let's try to
let's
look
try
at the
to look at the
problem.
problem.
So here
So
it
here
is being
it is
asked
being asked,
which of the
which of the
following
following
property
property
is
is
measured
measured
by
by
calculating the
calculating
area
the
under
area
the
under the
stress
stress
strain curve.
strain curve.
So
So
let's
let's
try to
try
quickly
to
make
quickly make the
a typical
a
stress
typical
strain
stress
curve.
strain curve.
So
So
y-axis is
y-axis is
sigma or
sigma
stress,
or stress,
and
and
x-axis is
x-axis is
strain
strain
or
or
epsilon.
epsilon.
So
So
we
we
most of the
most of the
material
material we get
some shape
some shape
like this,
like this,
but there are
but there are other
like
materials like
iron.
iron.
We get some
We get
different
some
shape.
different shapes.
So
So
we'll not go
we'll
there.
not go
But
there. But
what
what
what I'm trying
what
to show
I'm
that
trying to show that
this is the
this is the
typical
typical
stress
stress
strain
strain
curve.
curve.
So So
it is being
it is being asked
what kind of
information
which
which
we
we get
from this
from this
stress strain curve.
strain curve.
So first one
So
is the
first one is the
hardness.
hardness.
So
So
what is the
what is
hardness?
the hardness?
Any of you?
Any of you?
Can you please
Can
try
you please
to
try
tell
to
what is the
tell what is
hardness?
the hardness?
Or whatever
Or
it
whatever
means,
it means,
whatever
whatever
things you
things
have in your
you
mind, you
have in your
can
mind, you
tell
can tell
about the
about
hardness.
the hardness.
Anyone?
Anyone?
Or
Or
are you sure
are you
that we
sure that we
cannot get
cannot
the
get the
hardness
hardness
information from this
information from
stress
this
strain
stress
curve?
strain curve?
Please try.
Please try.
Okay, let's try
Okay,
to
let's
see
try
the
to see the
definition
definition
of the
of the
hardness.
hardness.
We can
We
see
can see
how hardness is
how hardness
defined.
is defined.
Hardness is a
Hardness is
measure
a
of
measure of
resistance
resistance
to
to
localized
localized
plastic
plastic
deformation
deformation
induced
induced
either by
either by
mechanical
mechanical
indentation
indentation
or
or
aberration.
aberration.
Yes, Vikram.
Yes, Vikram.
Yes, you are
Yes,
correct.
you are correct.
So,
So
if you see
if you see
hardness,
hardness,
it is a
it is
resist.
a resist.
Yes,
Yes,
Pratik, you
Pratik,
will get the
you will
PDF.
get the PDF.
Yes, you will
Yes,
get.
you will get.
So, if we
So if we
see,
see,
main thing is
main thing is
resistance
resistance
to
to
localized plastic
localized plastic
deformation.
deformation.
This
This
localized is a
localized
very
is the
important
very
word
important word
in this
in this
definition.
definition.
Let's quickly
Let's
see
quickly see
how
how
how we make
how
a
we make
sustain
a
curve.
stand
Any
curve.
of you can you
Any of you
tell?
can you tell?
Suppose
Suppose
we are given
we
a
are given
material.
a
Let's say
material. Let's say
I have given
I have given
you
you
uh,
uh,
iron block,
iron block,
and I
and I
ask you to
ask you
please
to
make
please make
stress
stress
sustain
sustain
of this
of this
iron
iron
of this
of
material.
this material.
So what will be
So
your
what will be
approach?
your
How you will
approach?
make?
How you will make?
Means what kind of
Means what kind of
experiment? What
experiment?
kind of
What kind
equipment
of
you will
equipment you
use?
will use?
Anything?
Anything?
Please
Please
feel free to
feel
discuss
free to
with me.
discuss with me.
Any thoughts?
Any
Any idea?
thoughts? Any idea?
So
So
what is stress?
what is stress?
Stress,
Stress.
Vikram,
Vikram,
I am talking
I am
about
talking about
if I
if I
if I have
if
given
I
you a
have given you a
material,
material,
let's say
let's
some
say
iron,
some
copper,
iron,
or
copper, or
anything,
anything,
and
and
I have asked
I have
you
asked you
how we will
how we will
make
make
stress
stress
strain for
strain
that
for that
material. How I
material.
will
How
make
I
this
will
curve?
make this curve.
What kind of
What kind of
experiment or what
experiment
kind of
or what kind of
equipment you
equipment you
need
need
to
to
draw this kind
draw
of
this.
curve? Yes, UTM. Yeah, correct. Correct. What we do in the UTM? So, okay. So what I will do? What I will I will take a sample material out of it, which is called tensile specimen. It looks like something like this. Yes, on UTM we will do elongation. So this kind of sample, this is standard sample. There are many standards like ISO, uh, international standard or European standards. So based on any standard, we make a sample from this whole material, from big chunk of material. We will make a small. It is called tensile sample. And what we will do, since we have to draw the stress strain diagram. So what is stress? If simply, if we don't go in detail, just we know stress is the load upon area. It is the load upon area. And what is the strain? Strain is nothing. If we talk about the engineering strain, it is a simple change in length, change in length upon original length. Okay. So what we do in the UTM, Universal Testing Machine. So we take this tensile sample. So and with the help of universal testing machine, we apply some force or load on this material. And if you know, if we apply some force on any material, what will happen? Anyone already have told? I think, yeah, Srinivas. Yeah, if we apply some load, then what will happen? The material will elongate. So in universal testing machine, what we get? We get the force values and elongation values. Okay, basically there are sensors which measure what is the change in length of this specimen happening. So the information which we'll get, change in length delta L and force reading at different points, and from this and this we try to plot this stress strain plot. Okay, what is, so since we have made this sample, we know the what is the cross sectional area. So area we will already know, as well as initial length. So here we are considering only this length. This is called the gauge length. So initial length, which is we are taking as L0, initial length and initial cross section area we already know. And from this machine, we got the delta L and force values or load value. From this, we calculate the stress and strain. Okay, but what actually has happened when machine has applied load on this sample? This complete sample has deformed. Okay, so this complete sample has deformed plastically. Okay, so here also we are deforming the material plastically, but here it is not localized. This whole gauge length is getting deformed. So from this we get this stress strain curve. Okay, and now from this curve we there are different deformations we get. So after this is the point till here, till here. This is called the elastic region. Basically, what is happening here? The material is deforming elastically. Elastically means the material will regain its shape if we stop loading. Okay, and the stress corresponding to this, it will be yield stress or sigma y. Okay, so after that the material start deforming plastically and we get this kind of curve. Here I am not telling each and every part of the stress strain curve, just I explain how to get stress strain curve from with the help of the universal testing machine. So this is the yield stress, yield strength, and there is a P of the stress value that is called ultimate tensile strength or UTS. That is the maximum value of the stress value we get during the this tensile test. So that is called the ultimate tensile strength. So from the stress strain curve, what, what what we can get? One is the strength. Okay, the hardness we cannot get because hardness is something different. Hardness talks about the plastic deformation in localized region. Suppose if we take this same specimen like here. So if you want plastically deformed in very small region here, and how much resistance this material provide for this small deformation, that is associated with the hardness. So there are other methods like Vickers hardness testing method or Noob's hardness testing method. There are other methods. So that I not talk about. So the main thing was hardness. We are measuring the resistance of the material to the local plastic deformation. So next one is the endurance. So endurance endurance is the term which is used during the cyclic loading of the material. So any material, it has a fatigue life. Fatigue life means it can survive to a certain cycles for given value of the load. So okay, let me try to show. I will erase other things. So here we are plotting stress versus number of cycles. So there are many materials where we get plot something like this. So what is we are showing here? We are showing that if, if we apply a cyclic load of sigma, or if we keep on applying the some cyclic load which is greater than sigma, the material will survive for certain number of cycle, and that is called the endurance limit or that minimum value of sigma or stress after which So that if we keep on applying the load, cyclic load infinitely, the material will not fail. That is called the endurance limit. Okay, I will repeat again. So this, if we apply some load less than this sigma E, suppose here, okay, if we apply some small load than sigma E and we keep on applying for a longer time or infinite number of cycles, the material will not fail at all. So this is called the endurance limit. So that minimum value of stress is called the endurance limit. So that has to done with that is to deal with the cyclic loading, and that is called the fatigue life. But that information that we not get from the this stress strain curve. There are fatigue testing is different domain. So from stress strain curve we cannot get that information. Third one is the strain. I told that from the stress strain curve we can get the yield strength and ultimate tensile strength. So as I already told, yield stress, after the yield stress the material start deforming plastically. So basically core material start deforming plastically, neither some localized region. Okay, and this ultimate tensile is the maximum value of the stress, and this tension word is very important. So maximum stress during the tension, that is the ultimate tensile stress. And toughness, this is the property which tells about the how much energy material can absorb before failure. Okay, so how we calculate it? Okay, once we got the material, we have drawn the stress strain curve. So it will look something like this. So if we calculate the area under this curve, then if you multiply the stress and strain, you will get the energy per unit volume. So for the given material, you will get the how much energy per unit volume you need to apply so that material will get filled. That is called the toughness. Okay, so from stress strain curve, we got the we can get the information of the strength and toughness. And if we talk about the particularly area under the stress strain curve, so that is called the toughness. So the correct answer is toughness. Okay. Okay. So I have explained this answer, but still, if any of you have any doubt, please let me know. Or any more clarification about any of these points is needed, please ask me. Okay, it seems there is no doubt. Please let's move to the next question. Please read the question and try to give a response in the polling section. I will create the polls. Yes, I have got a few response. Others, please give your response in the polling section. let's start discussing this question together. So here we are talking about the property of material that does not involve in permanent deformation. So let's try to look at stress strain curve again. Okay. So if you remember how we made this curve, so we took a material. So for simplicity, I am making like this. We started applying some load over it. Okay, and because of load, the length of material starts changing, and because of that, we got some curve like this. Okay, so up to here or up to yield point sigma y, this is the straight line. So under this region, so this is called elastic region. Okay, so if we deform the material little bit, or if we apply little force, okay, let's say any force less than sigma y, uh, actually sigma y is the stress. If we apply any stress less than sigma y, then what will happen? Material will deform a little bit, okay. But what will happen if we remove that law? Then again material will come back to its original length. Earlier it was of length L0, and we applied some load. Its length become L0 plus some dl, and we did again. If we remove the load, the material will come to its original length, that is L0. So that is called elastic region, and this property is called, this property of material, by virtue of it, by the virtue of with it regains its original shape for smaller values of the load. That is called the elasticity. Okay, so elasticity is this is the definition. Okay, this is the same what I have told. So what happens after this elastic region? If we keep on applying some larger load, okay, then the deformation will be little higher. Now let's say its length become L0 plus, let's say, 10 times of delta L, sorry, dl. So if we remove the load, so if we applied some higher load, let's say here some sigma, okay, and after applying this load, the length of sample becomes, let's L0 plus 10 times of dl, and then if we are removing the load, then what will happen? Then material will not come to its original length. Then after removing the load, material will, the length of material will become, let's say, L plus some, let's say, 5 times of dl. So some load, when we remove the, when we remove the load, then some of the length of this material will recover, but some length will not get recovered. So it will happen something like this. Okay. So when we applied complete load, this length we got L0 plus 10 times of dl, and when we remove the load, the final length of material will become L0 plus 5L. So this much of strain got recovered, but this much of strain now it has become permanent, and that is called the plastic deformation or permanent deformation. And these properties like ductility, malleability, plasticity, these all comes under plastic deformation or permanent deformation. So there are few minor differences. So in ductility is mainly for the plastic deformation of the material when we apply tensile load. Okay, if load is like this, so whatever deformation we will get, that is called the ductility of the material, or mathematically we can say ductility is L minus L0 upon L0 into 100 percentage elongation. That is how we define the ductility. So if we apply tensile load and deformation created by tensile load, that is called the ductility of the material. But what will happen if we apply compressive load? Okay, if we apply compressive load, then also material will deform, and that property of, so basically permanent deformation of the material because of compressive load, that comes under malleability. Okay, that is also permanent deformation. Only the nature of load was different, and if we combine both of these things, or some load in any arbitrary direction, and the permanent deformation because of load in any arbitrary direction, that is called the plasticity. Okay, so except elasticity, other three are associated with the permanent deformation, so they are not the correct answer. Only correct answer is elasticity. Okay, so any of you have any doubt? Is it clear to everyone? Please let me know. Okay. Okay, if it is clear to everyone, then I will move to the last question of the day. Please read it, and you can give your response in the polling section. I will create the polls. Yes, I have launched the poll. You can give your response in the polling section. Till now, I have received 2 responses. I am waiting for others. Okay. Okay, I will start discussing the answer of this question. So later on, if you can let me know if you have any doubt. Okay. The slope of stress strain curve in elastic region is known as. So again, I will make stress strain diagram. So here it is talking about elastic region. That is the elastic region, and it is talking about this slope. So the value of this slope, it is a material property, and name of that property is called modulus of elasticity, or Young's modulus. So many letters are used. Sometimes Y is used, or let's say E is used to represent the modulus of elasticity. So it is the material property that is fixed for any material, that is fixed for a particular material. Like if we have iron, it has fixed modulus of elasticity. Copper has a lag. So this is a fundamental material property. As I was telling earlier, if we deform the material to some value and then we remove the load, then if you see what is the slope of this material, what is the slope of the curve, unloading curve. This is called unloading curve. This is the loading curve. This is unloading curve. Here also the slope will be same because material is same. So let's quickly try to see what is happening in this region. I told that I took a material and now I started applying some law sigma. Okay, and because of this load, material will deform a little bit. And if this load is less than yield stress sigma y, then material will regain its shape. Now let's try to look at what is happening at atomic level. So this material is made up of different atoms. Okay, so when we apply small load, then suppose earlier material was like this. When we applied some small load, then there is a small displacement in the mean position of the atom. Okay, so now there is a small difference, a small gap. Okay, when we apply some load, let's say sigma. So because of this small load, the atoms will get little apart. But if load value is less than sigma y, then again it will come to its mean position, and again material will regain its shape. Okay, then again they will come closer. This is this is the this is the fundamental material property that is governed by the atoms. So that is called the Young's modulus, and the slope is same. So please remember the slope will be remain for given material. Whatever we do, this this slope will not change for given setup, given material. Okay. Apart from that, we know we from the stress system diagram, we can understand, we can find the yield strength y, and if you have seen the lecture, so here this transformation from elastic to plastic region is not clear. There we may there we may a line parallel which have the slope of Young's modulus, and it is offset. Wait, I will make another code. So suppose this is the stress strain we have got, and if there is no sharp change between the elastic and plastic region, then what we will do? We will make a parallel line with same slope, and that slope is what? That is Young's modulus. And this offset, it is the 0.2 percentage of strain. Okay, so after this offset, we'll draw a straight line. Wherever it will intersect, corresponding stress value is called the yield strength or sigma y. And if it is clearly distinguishable, then we don't need to do. Then directly we can visually we can see where this transformation happens. Otherwise, we use this standard method. So, modulus of elasticity, it is the slope of the stress strain curve in elastic region. And what is the Poisson ratio? It is defined for the if we have some planar material, and if we apply some load, sorry, then what will happen? Material will become something like this. So there is some strain. It will come in longitudinal direction or strain in longitudinal direction, and there is a reduction in some strain will come in transverse direction. So that is called strain in transverse direction. So if Poisson ratio is denoted by nu, this symbol is called nu. So Poisson's ratio is denoted by lateral strain or transverse strain upon longitudinal strain. That is the Poisson ratio. Okay, and percentage elongation is nothing. It is the same as ductility, that is defined as the percentage EL is the L minus LG upon into 100. So that is the percentage elongation. So I have told you all the definitions. So, but for if you concentrate on this question, the slope of stress strain curve in elastic region is give Young's modulus or modulus of the elasticity. Okay, so the correct answer is B. So any of you have any doubt, please let me know. Today's session is done. Today's problem solving session, we are done with this session. So still, if you have any doubt, please ask me. Okay, if there is no more doubt, then we can end this session here. We'll meet you next Tuesday at the same time. Okay, with the new sets of questions based on the lectures of the week 2. Okay. Okay. If no more doubts are there, then you can leave this meeting. Yes, yes, slide. You will get the slide. You will get on the there is you will get a section that live session section you will find in the same website of the NPTEL Swayam course. You will find it where you find the link for the downloading videos. There also you will get the link for the live session, and you can watch, and as well as you can find all the slides which we are solving here. Okay. Still, if any doubts, you yes, yes, you can give the recorded session. Okay. If you have any doubt, you can write on the discussion form. We are there for help you anytime. Okay, and you can ask me in the next session also if you find any difficulty. Okay, we are ending this session here. Thank you so much. Thank you so much, everyone. Yes, Shivam. Yeah, I was telling that if you still have any doubt, you can ask me in the next session. Okay. Thank you so much, everyone. Wish you all good night. Thank you. What about PDF? Yes, PDF you will get. Next session will be on the Tuesday, same timing. Each week we will have the same session. PDF you will get on the NPTEL website. Assignment, if you go in the assignment section, I think deadline for the first assignment is tomorrow. So if you have attended this session, then you don't find any difficulty to solve the assignments. Still, if you have any difficulty, you can ask me. Please keep on solving the assignment. That will add to your grades. And this type of question will help you to solve the assignment as well as your final examination. There you can score well. And if any doubts you find from the lectures, you can feel free to ask me. Yes, Suraj, I was telling that if you have any doubt, you can ask me in the next session. And still, if you have any doubt, I will wait. I can explain you again here if you have any doubt regarding the questions we have discussed here or video lectures of the course. Okay, so I am ending the session here. Thank you, everyone. Bye. Good night.